Alright, so today we're going to learn about adding and subtracting rational numbers. We're also going to learn about multiplying and dividing rational numbers. And rational numbers is just a fancy word, fancy two words for fractions. So you guys already know how to add, subtract, multiply, and divide fractions. So today we're just going to review it. We're going to skip this first section. We're going to not do the preview. We're actually going to go straight into the lesson. So first thing is reviewing vocabulary. Match each term with its definition by drawing a line to connect the two. Okay, some of these words may be new to you, some of them may not, but let's talk about them. A rational number. Well, I just told you a rational number is the same as what? And the answer was any number that could be written as a fraction. So we're going to draw a line to connect those two. Repeating decimal. Well, what does the word repeating mean? It means go on and on and on in kind of a pattern. It repeats. So it says a decimal that has a pattern in its digits that continues without an end. It's repeating, and it's repeating forever and ever. Terminating decimal. This is a decimal that results when the division of the numerator and denominator ends with a remainder of 0. It's a really fancy way of saying it's a decimal that stops. It terminates. It stops. So those two match. Okay? Write the definition next to each term. Like fractions. Like fractions are fractions that have the same denominators. So their denominators are alike. Unlike fractions are fractions with different denominators. So their denominators are not the same. Alright, let's look over here at the next page. We're actually going to do some examples. It says circle the pair of rational numbers, or fractions, that have like denominators. So all the ones that have the same denominator. So this first one, 3 and 9, 21 and 21, sure. And it's okay that this negative sign is out in front. They still have the same number in the denominator. And we have negative 1/12 and 5 and 11/12. And again, those denominators match. They're both 12. So those two guys have like denominators. All right, adding rational numbers. Find each sum, write your answer in simplest form. So this should be a review for you. First thing you need to know is that you need to make sure that your fractions are like, that they have the same denominator. So you have 2/9 and 3/9. They're the same. So then you can just add the numerators. 2 plus 3 is 5. So your answer is 5/9. 5/9. Okay, next one's a little bit trickier. They are like fractions, but you have a mixed number. So you got to change that mixed number into an improper fraction. So to start with, this gives us 3/8 plus, to change a fraction to a mixed number, 2 times 8 is 16. And 16 plus 5 is 21. So we have 21/8. So again, 2 times 8 is 16, plus 5 is 21. 21/8. And if we add those together, 3 plus 21 is 24 over 8. Now that's not in simplest form, right? This is still an improper fraction, so we have to think how many 8s go into 24? Well, that's 3. And there aren't any left over, so my answer is just 3. Next two, we have 4/5 and 1/10, not the same denominator, so we have to make them the same. The easiest way to do that is to change this to tenths. So change this 4/5 into a certain number of tenths. Okay, if I think 5 times what gives me 10, 5 times 2 gives me 10, 4 times 2 is 8. So that's 8/10. 8/10 and 1/10, 9/10. Next example, moving on over. I have 3/16 plus negative 1/4. Okay, well, not the same denominator, so easiest thing to do would be to make this into 16ths. Find that common denominator. So this gives me 3/16 plus negative, well, 4 times 4 gives me 16, so 1 times 4 is 4. Now with negative fractions, you can kind of pair that negative up in the numerator. So you can think about this as 3/16 plus negative 4/16. It means the same thing. So you do 3 plus negative 4, which gives you negative 1, and it's all over 16. So it's okay to have the negative up in the numerator, okay, or out in front, either one. All right, next example, we have negative 5/6 plus negative 11/12. Not the same. So again, common denominator would be easiest as 12. So negative 5/6 plus negative 11/12, and actually let me fix that because I didn't change my denominator. This is going to be some sort of 12ths, and you can go ahead and put that negative sign up there in the numerator, plus negative 11/12. 6 times 2 gave me 12, so 5 times 2 is 10. So I've got negative 10/12 plus negative 11/12. Keep that denominator the same. Negative 10 plus negative 11 gives me negative 21/12. Not in simplest form though, because it's still a improper fraction or an improper fraction. So I think how many 12s fit into 21? Well, there's only one. And how many more to get to 21? So I have 12/12, which is one whole. And then how do I get from 12 to 21? It's going to take 9 more. So that's 9/12. My answer is still negative, so we hold that negative sign. And then finally we have to simplify this last fraction. So that gives me negative 1. And I can divide both of these by 3 and 3/4. So a lot of work for that one question. All right, last one. This is a little tricky. We have a negative mixed number, and this might be something you haven't seen before here. So what I want you to think about is negative 4 times 20 minus 7 instead of plus 7. Or you can hold that negative sign. 4 times 20 is 80, plus 7 is 87. And we can pull that negative back out at the end. So you kind of hold on to that negative, you convert to an improper fraction, then you pull that negative back out and drop it straight down. It's probably the easiest way to think about it. Plus 6 times 20 plus 11. 6 times 20 is 120. Plus 11 gives me 131 over 20. A little bit tricky here. Negative 87 plus a positive 131. So I know my answer has to be positive because 131 is a larger absolute value. Okay, so I got to think about, let's see, 131 minus 87 will get you there. Okay, signs are opposite, so we subtract. So let's see here, 131, and I'm going to grab my calculator because I'm having a hard time doing this in my head. Let's see where that is. There it is. So I've got 131 minus 87. That gives me 44. So I have 44 over 20. 44 over 20, and again, that's positive. Then you have to think about how many 20s fit into 44. Well, 2 times 20 is 40, so I know I can fit at least 2 20s in there. So that gives me 40, and I have 4 20ths left over. 2 times 20 is 40, plus 4 is 44. You can always check your work. And then finally, you can simplify. So 2, you can divide both of these by 4. 4 divided by 4 is 1. And 20 divided by 4 is 5. So my final answer is 2 1/5. All right, helping you remember. A good way to remember a mathematical process is to explain it in your own words. Explain to a classmate how to determine the sign of the sum of a positive and negative fraction. So I kind of explained it back up here a little bit, but I want you to pause the video right now and think about how you might explain how to determine the sign of the sum of a positive and a negative fraction. All right. So hopefully you came up with something along the lines of the sign we'll take, the answer will take the sign of the fraction with the larger absolute value. Something along those lines. All right, let's go ahead and turn the page and we're going to talk about multiplying rational numbers. Okay, and again, we're going to skip the part where it says predict, and we're just going to go straight through this. Okay, so we're reviewing, right? A repeating decimal is a decimal that has a pattern in its digits that continues without end and is called a repeating decimal. A rational number is a number that can be written as a fraction. So any number that can be written as a fraction is a rational number. Fractions that have the same denominator are considered like fractions. Okay? Fill in the blank with the correct term or phrase. We're not going to worry about dimensional analysis right now. We're not there. Okay, and we're not going to worry about this right here. So we're going to skip those two. All right, moving on. Complete the table showing the signs of the product of the two rational numbers, then find each product. All right, so two positive numbers. First sign is positive, second sign is positive. Sign of the product is going to be positive, and then find the product. All right, my first sign is positive. My second sign is negative. Signs are opposite, so my answer is going to be negative. When we multiply fractions, we just multiply straight across. So 7 times negative 4 is negative 28 over 8. Okay, and we can reduce that or simplify that. 8 goes into 28 3 times. We're going to hold that negative sign till the end. It goes in 3 times. 8 times 3 gives me 24, and there's 4 left over. And you can give the negative sign back. And one more time, that can simplify down to negative 3 1/2. Negative 3 1/2. Okay. Next two, I've got negative 2 1/2 times 3/4. So my first sign is negative. My second sign is positive. Signs are opposite, so my answer is going to be negative. And I'm going to come over here to do my work because I need a little bit more space, and that's okay. So I remember I've got to convert these into improper fractions first. Negative 2 times 2 gives me negative 4, minus 1 is negative 5, or, hold that negative sign for just a second, 2 times 2 is 4, plus 1 is 5, and then give the negative sign back. So we have negative 5 halves, times, okay, 3 times 4 is 12, plus 1 is 13. And that's 13 over 4. Sometimes you can cross simplify. Here we can't. We're just going to leave it alone. Okay, so 5 times 13 gives me, 5 times 13 gives me 65, and I have a negative sign, so negative 65. 2 times 4 is 8. Put it back into a mixed number. How many 8s are in 65? Well, 8 times 8 is 64. Got my negative sign. There's my 8. Okay, and then from 8 times 8, 64, you're trying to get to 65, so I have 1/8 left over. So my answer is negative 8 1/8. Okay. Last example in this section. So we've got two negative numbers. The first one's negative, the second one's negative, which means my answer is going to be positive. Signs are the same. The answer's positive. So we need to convert both of these mixed numbers into improper fractions, and again I'm going to come up here and do that work. Okay, so hold your negative sign. 1 times 12 is 12, plus 1 is 13. So that gives me 13 over 12 negative. So we add that negative back in. Okay, hold the negative on the 3. 3 times 5 is 15. 15 plus 4 is 19. So times negative 19 over 5. Okay, 13 times 19 is 247. 12 times 5 is 60. My answer is positive. Now I've got to think about how many 60s fit into 247. Well, we can kind of think about this a little bit smarter here. How many 6s fit into 24? Well, 6 times 4 is 24, right? So 60 times 4 is 240. So I know there's 4. 60 times 4 is 240, and it takes me 7 more to get to 247, so 4 and 7 sixtieths. So my final answer, 4 and 7 sixtieths. Okay, so we fill that into the chart. We're not going to do this dimensional analysis example, so you can cross that out. We are going to do the division on the next page. Okay, so move on over to division. And again, we're going to skip this part here at the beginning, and we're going to review right here. Label the rational numbers with terms like fractions, unlike fractions, repeating decimals, and terminating decimals. So if you look at this one right here, okay, notice there's not a pattern, and it stops. So this is going to be a terminating decimal. A terminating decimal. Okay? These guys right here are like fractions. They have the same denominator, like fractions. This one, the little bar over the top, means that's going to be a repeating decimal. A repeating decimal. And then these two are unlike fractions. They have different denominators. So unlike fractions. Vocabulary. Complete the definition with the correct terms or phrases. Two numbers with a blank of blank are multiplicative inverses or reciprocals. Two numbers with a... that's an interesting. Two numbers with a... I'm going to have to look that one up because I am not sure what the answer is. Let's see. This is the Course 3 book, and we're dividing rational numbers. Well, I'm not sure, but I will get back to you on that one. Let me cross this out for now, and I will come back and make sure we get the right answer there. All right, multiplicative inverses. Write the multiplicative inverse of each rational number. So I do know what multiplicative inverse means. It means reciprocal. Multiplicative inverse of 17/18 is 18/17. And the multiplicative inverse of negative 23/28 is negative 28/23. Okay, in order to get a multiplicative inverse, we have to convert to an improper fraction. So 2 times 6 is 12, and 12 plus 5 is 17. So this is 17 over 6. Multiplicative inverse would be 6 over 17. And this one right here, we have to convert to an improper fraction first. Remember, we hold that negative sign. 4 times 9 is 36. 36 and 5 is 41. And we plug our negative sign back in at the end. Multiplicative inverse would be 9 over 41, still negative. 9 over 41, still negative. All right, steps to divide rational numbers, or to divide fractions. Okay, so to divide by a fraction, first thing we need to do is multiply by the reciprocal. So for example, 7/8 divided by 4/5 is 7/8 times 5/4. And we can solve that out. 7 times 5 is 35. 8 times 4 is 32. There's 1, 32, and 35, so that's a whole. 32 times 1 is 32. And there are 3 30-seconds left over. So in algebra, in symbols, A over B divided by C over D is A over B times D over C, where A, B, and C, or B, C, and D are not 0. So B, C, and D can't be 0 because we can't have zeros in any of the denominators. So that sums up our notes for today, and I hope you have a better understanding of how to do rational operations.